Hi, today I'll be talking to you about methylguanidoacetic acid, more commonly known as creatine. Creatine is a metabolite that can be naturally found in the human body and also in many animals. It is found mostly in muscle tissue, but can also be found in the heart and the brain. The average person's creatine intake comes from food sources such as meat and fish. What creatine does is it transfers energy to the cells of the body, primarily muscle, and increases the production of adenosine triphosphate, more commonly known as ATP. Although creatine can be consumed naturally through food sources, the amount of creatine in food is quite low. It is for this reason that many sportsmen, powerlifters, bodybuilders and the like supplement a synthetic form of creatine known as creatine monohydrate. This allows athletes to generate more muscular power and endurance, which results in increased performance and longer periods of training. Creatine is personally important to me because it helps me in my own training to increase the weights I'm lifting and also to increase my muscular endurance to provide longer training sessions. So you might be thinking, how does creatine do all this? What is the molecular structure? Ta-da! This is the molecular structure of creatine. The molecular formula of creatine is C4H9N3O2. The four black atoms are carbon, these three blue ones are nitrogen, the two red ones are oxygen, and the surrounding 9 white ones are hydrogen. As you can see, there are two double bonds. The first one is between carbon and oxygen. This occurs because carbon has 4 valence electrons but only 3 bonds, therefore it wishes to create a double bond with oxygen. The second situation is quite similar. You have a carbon atom with 3 bonds but 4 valence electrons, so it makes a double bond with the nitrogen here, which has 5 valence electrons, one of which is being used to bond with hydrogen. As you can see here, the 3 hydrogen atoms that are bonded to carbon are evenly spaced. This occurs due to the hydrogen atoms having the same electronegativity of 2.2. A similar situation can be seen here between the 3 carbon atoms and the 1 nitrogen. In this particular part, you can see a bent shape between the carbon, oxygen, and nitrogen. This occurs due to the carbon having a stronger electronegativity of 2.55 compared to hydrogen's 2.2. If they were the same electronegativity, it would be evenly spaced in a straight line, but because of carbon's stronger electronegativity, it pulls the hydrogen around to be closer. One of creatine's useful properties is that it is soluble in water, which makes it easier to consume. When we do physical activities and use up our energy, what happens is that ATP is converted into ADP. When creatine is ingested, it turns from creatine into phosphocreatine, which can be seen here. The main function of creatine is that it gives us more energy by creating more ATP. As you can see, the only difference between ADP and ATP is 1 phosphorus, 3 oxygen, and 1 hydrogen, all of which can be found on this branch of phosphocreatine. So what it does is it donates this phosphate ion to ADP, which turns it into ATP and gives us more energy and allows greater athletic performance. So thanks for watching my chemistry vlog. I hope you enjoyed and I hope you learned something new.